Hi everybody, how are you all? Hope you are doing great. Welcome back to today's session of learning physics again with me. Before beginning, I would like to request please subscribe the channel Tangent Academy. Also like it, share it with friends too, so that you can get one video every day, either physics or math problem. Without losing time, I want to start. Today our topic is inertial mass. What do you mean by inertial mass? So, according to Newtonian second law of motion, you can write it according to Newtonian second law of motion. As I discussed before, force is defined as mass into acceleration. Force is defined as mass into acceleration in magnitude. Therefore, it can be written as acceleration will be force by A. So force by mass. Acceleration will be force by mass. You can clearly see here, acceleration is inversely proportional to mass of the body. Larger the mass of the body, smaller is the acceleration produced in it by a given force, and hence greater is the inertia. Larger is the mass of the body, smaller will be acceleration produced by the external force F. So, larger is the mass of the body, smaller will be acceleration produced by the external force on it. Mass accounts for linear inertia of the body, is called inertial mass. Again listen, mass accounts for the linear inertia of the body, which is called inertial mass. Mass, it is a notable thing, mass account for linear momentum of a body which is called inertial mass, mass account for the linear momentum of a body which is called inertial mass. So, if in the given relation, if A is equal to 1 unit chosen, if A is equal to 1, then force will be equal to mass in acceleration, mass in magnitude, mass in magnitude. Force is equivalent to the mass in magnitude. So what is inertial mass? When acceleration is equal to taken as 1 unit. Acceleration is taken as 1 unit. Inertial mass can also be defined as the force required. Inertial mass can also be defined as the force required inertial mass can also be defined as the force required or produced unit acceleration in the body. To produce unit acceleration in the body, momentum curve. Now I will say momentum time curve, PT curve, which is known as PT curve, momentum time curve. Let us draw the axis. This is curve. Let us suppose here is at any point there is a tangent whose inclination is theta. Inclination means angle made by anti-clockwise direction, positive angle, which is taken as positive angle. Let us, this axis represent momentum and this axis represent time. This is called PT curve. Let us see what thing represents by PT curve. Momentum PT curve. So dP by dt So dP by dt is equal to tan theta, which is equal to force, as we already know that rate of change of momentum is force. We already know that rate of change of momentum is force. Here rate of change of momentum dP by dt is equal to tan theta geometrically. Tan theta geometrically, where theta is the inclination of the tangent to that of curve. Tan theta is equal to force geometrically. So dP by dt is equal to force, implies dP is equal to F dt. Therefore now we will integrate both the sides under the limit of integration T2 and T1 and P2 and P1. Integral of dP F times integral of dt under the limit T2 and T1 under the limit P2 and P1. Here F is constant, so F can be taken out from the integral sign. Just a moment, please. Integrating both sides, P under the limit P2 and P1, F T under the limit T2 and T1, upper limit T2, lower limit T1. Putting the limit P2 minus P1 is equal to F times T2 minus T1. And we know that T2 minus T1, P2 minus P1 is equal to F times T, F times T, T2 minus T1, change in time, P2 minus P1, change in momentum, which gives you impulse, which gives you impulse. Here you can see the figure of, let us the curve is as shown in the figure. Here this is origin. At time T1 the body is at here, at time T2 the body is at here. A small slice of wide width dt is taken. So change in momentum is equal to force in time. Change in momentum, change in momentum is equal to force into time, which will gives you impulse, which will give you impulse. Thank you for watching. I hope that you will it will be helpful for you. Like it, share it. Also like it, share it. I will take a new video next day. Till then, take care and bye.